Okay, so this chapter is on congruent triangles. We're going to learn lots of ways to prove triangles congruent. In the first couple lessons, we'll basically have to prove all parts of things congruent in order to say that they are so. But as we progress forward, we'll learn a few shortcuts that help us make our lives a little bit easier. So first one, we're going to discuss angles of triangles. Some of this stuff is stuff that you've learned before, so you should know or at least recall with a little bit of prompting. But for our learning goals for this lesson, we're going to be able to classify triangles by sides and angles, and we've done that before. You'll remember what I'm talking about when we get there. The other thing we're going to do is find interior and exterior angle measures. And again, it's stuff we've all done before. We'll just kind of discuss the difference between interior and exterior angles of triangles. So first of all, classifying angles by sides. And again, we've seen this before. If no sides are congruent in a triangle, they're called scalene. If we have two of the three sides congruent or equal, they're isosceles triangles. And if all three sides of a triangle are congruent, it's called an equilateral. Now, along with an equilateral, kind of going backwards here, along with an equilateral triangle, we have equiangular triangles. So if I know all three sides are equal, I also know all three angles are congruent as well. So you don't see equiangular a lot just because it's kind of implied with equilateral. Now, the other three we see pretty regularly. We have acute triangles. All the angles are below 90. We have a right triangle where it's one right angle, and then we have an obtuse where it's one that is greater than 90 degrees. So again, a lot of these terms are familiar. We've used them before. We've seen them in math, and we kind of know what they mean. So our first example here, and we don't necessarily need to get out a measuring thing like it says. We can pretty much eyeball it and tell here this angle at the top is really our only shot at being a 90-degree angle, and you can pretty clearly see that that's not the case. So in terms of classifying it by angles, we would call this an acute triangle. Now, in terms of classifying it by sides, again, you can see the notation on here. Those are marked congruent. So because we have two of the three sides marked congruent, we know that it is an isosceles triangle. So it's an isosceles acute. We will classify by sides and angles. Again, we really don't need the protractor to measure here. We should be okay without it. So, and I slid down, you can see it there. The monitoring progress says to draw an obtuse isosceles triangle, and it's really okay that you saw that, and an acute scalene triangle. So really quick, understand if you're asked to construct something on a quiz or a test, more importantly than just drawing it so that it passes the eye test, is let's say that I have that obtuse isosceles triangle. So this looks like it's an obtuse this looks like an acute scalene triangle. I think I didn't put the obtuse isosceles, so we can draw that one here in a second. But here's the thing. This could be used as either or just based on what I label things. So for instance, if I want this to be my obtuse isosceles triangle, I could just label this angle right here at the bottom. I could say, you know what? This is 91 degrees. And then if I want it to be isosceles, I can say, fine, it can be isosceles. I'm going to mark this congruent to this. Now that's an obtuse isosceles triangle. Now, let's take that exact same image, okay? We'll undo those things and say it's an acute scalene. Fine, we can draw it however we want, and I can just as easily argue that this is 89 degrees. Again, if you just draw it and label things, it's fine. You don't have to be identical. And in order for it to be scalene, all three angles have to be different. So let's say we have 89 degrees. Let's say we have 31 degrees. And let's say this is 60 degrees. As long as the sum of those three angles is 180 degrees, I know all three of those sides have to be different shapes, or different sizes as well. So this would work for either image, just depends on how you label it. Okay, so labeling it is pretty big. I'm not going to ever get out a protractor and measure it exactly. That's what those construction things are for that we have from time to time in class here. Classifying a triangle in the coordinate plane. So now, again, we can't really tell just by looking at it. So what I need to do if I want to decide if this is a right triangle is I want to look and see if there's a right angle right here. And the way I do that is by testing the slopes. If it's a right triangle, I know right away that I can say that my slopes should be negative reciprocals of each other. So they have to be negative reciprocal slopes. So if I were to do the slope from P to O, the slope from P to O, it's down 2 over 1. If I do the slope from O to Q, I can see that the slope has a rise of 1 and a run of 2. So this is indeed a 90-degree angle. I know that this is already a right triangle. The next thing I want to do is I want to do the distance formula real quick just to make sure that it's not an isosceles right, because it appears almost that PQ could be equal to OQ. So I'm going to run the distance formula really quick on those just to be certain. PQ, let's do that one first. So let's say 6 minus negative 1, and we have to square that, plus, and then we're going to do 3 minus 2 squared. 6 minus negative 1 is 7 squared, plus 1 squared. So we get the square root of 49 plus 1 is 50. So that's what we get for that one. Now, I could simplify it, but I really just want to make sure that OQ is not the same. So if I do this for OQ, it's 6 minus 0 squared plus 3 minus 0 squared. And I get 6 squared plus 3 squared, which gives me the square root of 36 plus 9, and that does not give me 50, that gives me 47. So I know that those are not two congruent sides. So now I know for sure that this triangle is right, and I know that, well, obviously this one's not going to be the same size as those other two, so I have a right scalene triangle. So that's how we would classify that one, by angle and by side. Okay, so again, I keep scrolling. Pause it here, you guys, so that you can see that. Go ahead and plot those points and try and classify the triangle. Again, determine whether it's right. You can obviously go back and pause and look at it if you want. I'm going to slide up and show you the answer here in a moment. But take the time to work this out in your notes. And like I said, it will help you determine whether or not you have certain types of triangles. Okay, so the work that I showed to the right, first of all, is I found the length of all three segments, and you can see that AB and AC have the same measure. So because that's the case, we know that we have an isosceles triangle. The next thing I did was I found the measure of angle A because it appears to be a right angle. And as you can see, the slope of AC is -1, and the slope of AB is +1. Those are negative reciprocals of each other. So this, instead of a right scalene, is a right isosceles. So we have a right isosceles triangle. All right. So again, make sure you go back, look that over, rework out. I have the work there for my distance formula, but I worked that one out above so that you could see how those are kind of worked out. The next thing we're going to discuss is interior and exterior angles. And again, it's pretty straightforward. Interior angles are on the inside. Exterior angles sometimes get confusing for students because when they think of interior, they think of the stuff inside, and then they assume sometimes that exterior means everything else. Exterior angles are simply what would form a line with the interior angle. So if you extend, and it doesn't really matter which way, but if I were to extend either one of these line segments into a full line, the continuation of it would be our exterior angle. So our exterior angle should have a linear pair with our interior angle. In other words, they should add up to 180 degrees. So then we have the property here again, and you really don't need this theorem. We've known this for quite some time, that all of the interior angles of a triangle should add up to 180 degrees. Now, the way we can do this and get this is by doing the triangle sum theorem proof. So if we look at this triangle, they kind of help us out in setting this up. And this is the one time that you don't have given to start off a triangle, but because we had to construct this parallel line, we're allowed to do this because of the parallel postulate. We can take any point that's not on a line and construct at least one parallel line through it. Again, that wasn't given, we constructed that. The reason we constructed that is because we should know what the sum of those three angles are because they form that line. So as you can see, we have the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5. We can add those all up using the angle addition postulate, and they form a straight line. So you can see there that it kind of has two different explanations for why we're allowed to do that. Okay, now moving forward, we have angle 1 and angle 4 are congruent. So if we look, first of all, some key notation here is that there's some red arrows. Again, those mean parallel. And then we're given that 1 and 4 are congruent. Why is that? Again, if we recall clear back to chapter 3, we know that because those are alternate interior angles, as well as 3 and 5. Those are also alternate interior angles. So these are some things that will pop up this chapter from time to time. We'll have to recall some of those properties that we learned back then. Okay, the next thing is definition of congruence. Again, when you see me write this out sometimes in class, you'll see it like this. It simply means a change in notation. So we took those shapes, those angles, and we said the measures of them should also be congruent. And then our last line, what we're trying to prove, and we're substituting now, because before we said angle 4, now we're going to use angle 1. Before we said angle 5, now we're going to use angle 3. So we can simply put measure of angle 1 plus measure of angle 2 plus measure of angle 3 should be equal to the same thing as up above, 180 degrees. And we did that by substituting in those values. So again, there's the proof of why triangles have a sum of 180 degrees on the inside. The exterior angle theorem, and again, this kind of goes with what we just talked about, but if I take an exterior angle and I compare it to the interior angle it's attached to, we know that these two should have a sum of 180 degrees. So what they do is they take this theorem and they say, well, if I know that this angle and the other two angles inside my triangle have to add up to 180 degrees, wouldn't that mean that the exterior angle should be equal to the measure of those other two combined? And that's simply what they have here. So again, it's one thing to copy down these notes and see the picture. It's another to make sure you understand what that just meant. So again, if these form a linear pair or add up to 180, it should make sense to us that just that exterior angle should be congruent to the other two, because A and B should also add up to 180 with that measure of angle C. So kind of get the gist of what these mean sometimes, not just copy it down. So again, when we go to set up this example off of that theorem we just learned, we know that that exterior angle, 2x minus 5, should be equal to the sum of the two non-adjacent interior angles. So the adjacent one is angle K. I should be able to add up the other two and find the value of x. So if I subtract my x over and I add my 5 over, and again, I kind of did that all in one step, but I get the measure of that angle x is 75 degrees. And again, if I want to find JKM, like the problem says, I'm going to plug 75 in for x. So 2 times 75 minus 5. 2 times 75 is 150 minus 5 is 145. So we get 145 degrees. Okay, we have a corollary. Again, corollaries are things like they can be proved easily without using theorems and things like that. So again, if I know I have a right triangle, all this one is saying is if I know I have a right angle in my triangle, I know the other two have to add up to 90 by default because the sum of all three is 180. So really, it's just taking a step out of a problem for us. So you'll see something like this in your homework as well. It says the painting has the red triangle in the painting is a right triangle. The measure of one acute angle is twice the measure of the other. Well, I don't know either one. So I'm going to call this one x, and I'm going to call this one 2x. And I know what their sum should be because it's a right triangle. I know 2x plus x should add up to 90 degrees. So I'm going to combine like terms, and then I'm going to solve for my variable, and I get x equals 30. So I can find the measure of the two angles. Well, one of them was just x, and 2x, if I take 2 times 30, I have a 30, 60, 90 triangle in there. So that's what I get. So the last two here, again, you guys can pause. I'm going to work them out super quickly, and then you guys can see what you get. So 5x minus 10, let's erase that plus, equals 3x plus 40. If I subtract, I get 2x equals 50. If I combine and divide, I get 25. Again, if I want to find the measure of angle 1, here's the part where you have to make sure you go back and answer your problem. So if let's say I plug in that there, 5 times 25 minus 10, I get 125 minus 10, I get 115, and I know that those two are supplementary. So I'm going to take 180 minus 115, and I get 65 is the measure of angle 1. Next one, I know that those two have to add up to 90. And it wants the measure of each acute angle, so we'll plug that in. 2x equals 64 degrees, and x minus 6 is equal to 26 degrees. And again, the sum of those should also be 90, so make sure they are, because if they're not, something is not right. Okay, so in summary, again, we were using the angles of triangles. We learned a couple theorems. Again, some of it was new. The stuff that was new, though, was kind of common sense stuff that we could kind of pile on to stuff we already know. The assignment's there for you. You can see posted. Make sure you guys always ask if you have any questions. Thanks, guys, and have a great day.